So let's go to in MySQL Workbench, we'll go in the models and we'll create a new model for the examples in this lesson. And initially, there is nothing to save, but if you call saving, you will get a pop-up menu and you will be asked to save, which I strongly recommend. As you start working, it's good to save because you don't risk to lose your work. So this is a week 3 session 1, and I will put here in all the work that we'll do today. Now, my goal is to take one conceptual example and to play with it so that we'll be able to see between pretty much same entities how the wording of a relationship will change the type of the relationship and how we can identify which is a type in each case. So let's first formulate type of relationship, and I will take first typical relationship. Let's say we have two entities, advisor and student. And the first story is that we have an advisor has many students assigned, but and a student will be assigned to only one advisor. And now to make it a little bit even more clear, I will say a student may not have an advisor assigned when enrolling to the school, college, or whatever we want to put here. So this will be a kind of specification. And again, here I am not very worried about attributes for this student and advisor. Here we'll be worried mostly about the type of relationship. So I will not put all the attributes in my discussion. I will just put the main elements that appear. So let's go on. I have two entities, advisor and student, and we'll need to decide on these two entities what they represent. So let's take now one entity, and I'll put here advisor. And what we like to do is to put minimal number of attributes. So I may have an ID or a code that will be the primary key, and usually this is the typical way to keep persons in a database. You have a surrogate key or you have a real ID that you use. Then you will have some kind of first name, last name, and so on. I will just put here first name just to have another attribute, but I will not write all the other attributes. And bar char of 45, it's a little bit too much. I will put 25, or you may have other requirements. Again, I don't care much. It's not null, but and maybe duplicated because many people may have the same first name. So again, this is just to have something. It's not complete, but for our purposes, it's enough. So this will be my first entity. My second entity will be the student, which will seem to be the same thing. here. I will need to have student. And again, I will not put all the information about the students, but similar reason advisor, I will need to have some kind of primary key. Let's put an ID. And then I will need to keep the first name and other information. And again, to be consistent, I will have here first name, and is just required, no other element. Now, this was what what we learned previously. Now the question is what? So it's clear that I have a relationship, right, between these two. It's clear that I must have a relationship. Now, how I determine what type of relationship I have? And there are two main questions that I need to ask to determine. First, I will need to look at one advisor. One advisor. So I'm looking just at one advisor, and I am asking myself, how many students, if I'm looking at one advisor instances, at a specific advisor, how many students might be in relationship with this particular advisor? And sure, it will vary depending on the specific advisor. It will vary, but it will be this is the main idea that I want to answer first, and I will write it here so it's clear. So one advisor, a typical instance, a typical entity instance. So again, doesn't mean that I will not have exceptions to what I am writing here. Sure, I can have. How many students associated? So, and I need to look, okay, how I answer that, you may ask, okay, how you answer that? You need to look at the specification. So I will sorry. So I will this is what the problem is telling us. And sometimes the specification is clear, like I make it here. So here the specification was very clear, but sometimes the specification may not be so clear. So sometimes I need to guess, I need to make an assumption. But here the specification is telling me. So which is the answer? So yeah, it will be a one-to-one relationship. You are right, but I'm trying to show you how we determine that. So we have many what? Many students. So if we look now, so I determine that I have many what? Students. So the student will need to have the many part of the relationship. That's very important that we determine right now. Now, it's not enough. Many people will stop here. Many students, when you do the analysis, will stop here, but it's not enough. So the next thing that I need to do the same thing from the other entity perspective. So now I will take one student, typical entity instance. So again, a typical one. You may have exceptions, but that in general. And you need to, your general may cover, you may say many, or you may say, oh, I may have none, one, or many. This is even more clear if we, and generally that's what you will do, because you may look and this will give you more information. But for the purpose of type, it's enough to determine that you have many. And generally, when you determine the type, you are interested to see the most of them, how many most of them might be. So that's what we are looking at when we look at the type. So how many advisors may have? And here again, if we look at the specification, we have an advisor has many students assigned, and the student may be assigned to only one advisor. So I can have only one advisor. And so I know that I cannot have two advisors for the same student. So the maximum is one. So the typical will be one. So, and again, I put advisors there, so it will be clear for us that it's about advisors. Sure, you don't need to write this when you solve your homework, but in your mind, this process needs to take place. So what I determine now is that I have one advisor and many students. So I determine a one-to-many relationship between advisor and student. So that's all I did up to now, nothing else. Now, there is also something that I generally need to do before I can draw the relationship in MySQL Workbench. I need to decide if this is a strong or weak relationship. And there are many ways to decide that. Basically, it's based on seeing if I have a entity that is dependent on another entity to exist. That's a conceptual term. More, like a technical rule to do that is to look at the primary keys. Generally, if the primary keys are independent, they don't share any kind of field, then means that these two entities may exist independently. So the relationship between them will be weak.
Okay.
So why? Because I can have an advisor, I can have a student, they don't require one another to be present in my database. So being weak, I will need to make it with a dotted line. So not a strong line like here, but a dotted line. And you see, you have one-to-many. It's this type of relationship. And you click on the many parts and on the one part, and you got the relationship drawn. Also, you got the foreign key already there for you. So sometimes you need, mostly in the homework, you need to edit it because you need to put your initials in it. But that's another story. So now I have this relationship. I draw it, but it's still not enough. If you don't see the name of the relationship, and this is something that many people will encounter, means that your settings are not so good. So you need to go in model, and then you need to go in the option, in the file option, in the main menu, you have model, and then you need to go in model options, and there you have one of the options will be to look at the diagram. And in that one, you have for relationships or connections, you have the option to show captions. If that option it's not present, then you need to click on it. So to click to see the captions for your relationship. So now what I will do, I will take them out. I have them, but I will take them out. And you see the name doesn't no longer appear on the relationship. And you will say, oh, how I add the name? And some people will put a text there. No, don't do that. So again, you go in model, model options, then diagram, and then show captions. And those will put back the name associated with your relationship. And there are basically two names that you can see. There is a main caption and the second caption. I usually use the second one. And that's what I recommend because sounds better. An advisor here you may formulate in many ways. An advisor advise students, student. Advisor advises student, but you can put it differently. So doesn't matter the name. So now we solve another problem. We give a name. The next part that we need to do is to decide on participation, and that's very important. So how I decide on the participation? What the participation is? If we look on the diagram, the line, you see near the advisor, you have two lines. First line to the left represent the type. It's the one from the advisor. So first line to the left represents the type. That's why it's one. Same to is the student. You have this line, and the student ends with three lines that go in the student. Those three lines represent the type, because that I have many students. So the outside symbols represent the type of the relationship. Now, what about the inside symbols? The inside symbols, they represent the participation in the relationship, and you may and in a way it's related to the cardinality of that one. So you may have mandatory or optional participation. If it's a 1, means that I must have one, which means mandatory. If it's a 0, means that I may not have one and make it optional. So these are the rules. Now, I may have, let's look at both situations. For a student, I know a student may not have an advisor assigned when enrolling to the college. So a student, I may not have here a corresponding advisor, which means that here I need to make it optional for the advisor. So a student may not have an advisor, so the advisor will need to be optional. And how we do that, we go on foreign key part, and we have the option to mark if the student or advisor is mandatory. Now both of them are mandatory. So if I make it optional, you see, as I took out mandatory, it became optional, and I have this circle like an O from optional that will tell me that I have 0 or none advisor for a student. I may have. It's not that I must have, but I may have this situation. So we clarify that advisor is optional. Now, for the student, I don't have any kind of indication. And here I say, okay, an advisor has many students assigned, and it sounds like always must have many students assigned, which you may say, okay, yeah, it's correct. And based on the specification is correct. We'll not have a clear differentiation. And if you put in mandatory, it will be correct. However, if you think it's a problem, you may have the same problem with advisor. So I hire a new advisor, I put it in the system. I will have a moment in my database when that advisor does not have yet any student assigned, or when they, if the advisor, it's year based, let's say, all the students went in the next year. So I may have in the life of the database moments when an advisor has no student assigned. So if this is possible, then we need to make student also optional, because I may have in the life of the database a moment in which an advisor will be with no student. So imagine that the advisor will take a leave of absence for a period of time. So what I want to say here, and generally in my problems, I am clear what the situation is. But this is a clear indication that we miss something. So what we'll need to do now is to refine our specification, or to put an assumption if there was no assumption in the specification and I cannot refine. If you judge it based on this wording, it's good how it is. But if we refine and say an advisor may have no student assigned for special situations, and I'll put here leave of absence, for instance, then this entire diagram needs to be refined, because now I know that the student may not be there. So I will need to go back and again put also student as being optional. Now, unfortunately, many times the specification are not at this level of details. The specification will be more vague, and you will need to think and put on paper everything that is missing. So, oops, didn't save this one. Okay, let me try again, because foreign key, yeah, I didn't save it for some reasons. Okay, now it's good. So now I have a good both specification and diagram. So if your specification is not at this level of clarity and you have an idea in your mind why you want to put it optional or mandatory, then you need to clarify, put an assumption that clarifies the situation. Okay, like we did here. Here we made a very specific situation. Good. Now, this is like a full relationship described. Let's imagine now a few other situations. And I will start with another typical situation. And let's put it here. So I will just refine, I will put here advisor 1 and student 1, just to represent that this was my first situation. Now, the next one, and I don't know, let me see if I can paste, yes. So the next situation that I would like to describe here will be similar with this one, but now I will say advisor has many students assigned, and the students may be assigned to one or more advisors. Students must have an advisor assigned when enrolling to the college, and we'll keep the other one like it is. So so this will be like the next kind of situation when I have the same two entities, advisor and students, but now I have an advisor that has many students assigned, and the student may be assigned to one or more advisors. So I will, if we repeat the same questions here, okay, and I will also take these particulars. Okay, so this will be now our advisor 2. And I will take also the student. And sure, it's taking this relationship. I will delete the relationship because I don't want it. Delete. So I just wanted the student, and I will have student 2. So just to facilitate the description here. Now, let's move to this second situation. And what I would like to do next is to answer these two questions to identify what type of answers I have. So now it's your chance. I will. I know I talk too much for now, but now I will start asking you to help me. So this will be like week 2. I think it's question 2. I had a question before. No, this is week 3, session 1, question 2. So let's take the first question. How many students are associated? And which will be the answer? So basically, you want to refine this part. So read the specification and see what specification is telling us. Many, very good.
Yeah, I said
So
many.
yes, so very good. So it's basically the same. I didn't change that part. An advisor has many students assigned, so it will remain many. Now let's look at the next question.
There'll be many as well.
That will be many as well. So let me write your question number so you will have it there. So there you'll have also many. So now we no longer have a one-to-many relationship, but we'll have a many-to-many relationships. And the problem with relational databases is that they are very bad at representing many-to-many relationships. And what they need what is named a bridge, another entity between these two that will keep that relationship. And let's think why we need that bridge. Let's think, an advisor, I need to have like a list of students for that advisor. Yeah, how we did before, we kept in the student a link to the advisor. And this was enough because I have a unique value here. So I have a unique advisor, the foreign key here, that for each student will keep the advisor, will keep like only one parent that this student may have, the only one instance to which this student may be referred. So having here a field with a single value will be enough. But now I need to do this both for the student. So I need, in a way, a foreign key in the student to know what advisor it is. But that advisor can be many, because a student can have many advisors. So basically that field, it's a multi-value attribute. And we know that we cannot represent multi-value attributes easily in relational databases. So therefore, putting a foreign key in any of them or in both of them will not help me, will not allow me to put for an advisor or a student all the matches that were performed. So that's why I need another entity in which I will put only these matches, this advisor, this student, this advisor, this student. So I will just keep a list of matches between advisor and students, exactly describing which advisor is in relationship with which student. So this is what the bridge is. It's something that helps me to define how they are connected. And you see, by default, if I create that, it will add me, if I use a many-to-many relationship in Workbench, it will create this bridge and link both advisor and student with a bridge. And you may say, okay, it's done for me. Not really, you still have work to do. So let me put it in a much nicer way here, because I don't like how the relationship are represented. Still, I don't like how they are represented. They will come over my, normally what I do, and that's what we'll do, we'll make it, we'll make space between them, then they will look much better. But you are not done. So we just started now to make the diagram. So first of all, let's go and look at this bridge. It has a very bad name. So what we like to do first is to rename it. There are many ways to do it. This is one way, when you put advisor has student, like the relationship name, and that's, that's okay, but it's not. Another way, much simpler, is just to put the two names, advisor, student, or you can say advisor per student. And I will keep here two, just to know that this is my second example. So that will be like a composite name. Sometimes this can be replaced with a better, meaningful way. For instance, in this case, I can name this assignment. If this is just for, this database is just for advising, like we have, it's much easier to name it assignment, because it will show me the assignment between an advisor and a student. If I have much more stuff in it, I can make it much more clear, saying, for instance, advising assignment. But as you can see, I can still give a good name to this relationship, not just putting the two initial names that the relationship was created automatically. So I have advisor student, and now I have the assignment between them as a different entity. Okay, now next step is to refine each of these relationships between an advisor and assignment, and between a student and an assignment. And by default, they are one-to-many relationship and must stay like that. So there's not a problem. There will be one-to-many relationships. And the participation of advisor must be required, because I will not have an assignment if I don't have the advisor in that assignment. So this part, it's pretty decided. Same with a student. I must have a one-to-many from student to assignment, and the participation of student, it always be required. So you see, the right part, it's pretty much decided. The type, many, for the assignment, it's also decided, because an advisor can have many assignments and the student can be part of many assignments as well. So the many part, the only thing that I still need to decide is a name, which looks horrible at this point, and the participation of assignment in these relationships. So basically, if here is mandatory or optional. So these are things that I still need to decide. So let's take one of the relationship. So the first one will be between advisor and assignment. Here, generally, I am looking holistic, globally, at the goal of this bridge. And I will put, for instance, advises. And surely you may say, okay, doesn't sound good. Advisor advises assignment. Yeah, advice is based on that assignment. But to be shorter, I will just put advices. And basically, I have in mind the student from the assignment, because this bridge is just a way to represent the many-to-many relationship. So, and again, it's the second caption. Always use the second caption, because it's advisor advises assignment. You can use the first one, but it's from my perspective, it's a little bit less clear. So many people are looking from the foreign key. I am looking from the parent to the child. You can do both ways, but be consistent. Now, I have this, and now I need to look if an advisor may or may not be, if an assignment, it's optional or mandatory. In other words, for a given advisor, do I need this advisor to be in a assignment? And I still have an advisor may have no students assigned for special reasons, like leave of absence. So here, assignment may not be present. So again, it's the only thing that I need. Advisor must be present. So if I have an assignment, I must have an advisor, because it's the role of the advisor to link an advisor assignment. It's linking an advisor with a student. So that's the role. So really, I need to have the advisor to be able to create an instance in the assignment. So that's why advisor is mandatory, and don't change that. But assignment, based on my specification, may not be present for a given advisor. So I must make it optional here. So we finalize the left-hand side, and now looks much better. As you can see, I can even bring it closer here. And I have space to bring this one closer here. So now I can look at the student to assignment, right? So it's just the relationships that we need to decide. And you see that by default, this relationship is strong. So the previous one was weak, it's dotted. This is strong. Why is strong? And again, we have this primary key kind of rule, because you see, the foreign key, the advisor ID, it's part of your primary key, right? So here, the primary key contains the foreign key that is related to advisor. And that makes the relationship strong. Why? Because I cannot have an assignment without an advisor. make no sense because the assignment is between an advisor and the student. Sure, make no sense to have an assignment entity if I don't have the advisor entity. So to exist, this assignment entity is really requiring me the advisor entity to exist. That's why it's strong. It's a relationship that it's strong. I cannot delete that relationship without losing entities. That's various interpretation of the idea of strong relationship. Okay, so we decided that. Let's now look at the student part to the advisor. So give me, this will be the question 4 here. Give me a situation in which you want to have, what name you'll put to this relationship. So first of all, let's decide the name. So like we did before, try to find a good name here between student and assignment.
Maybe assign.
Okay, that's good. You may say assign or advised by.
Yep.
So both of them are good. So these are good. Don't forget to put them in your chat so you can have them for bonus points. And then we'll go to question 5. Now, the next thing that we need to decide, and I'll go back to the specification, is this is optional or mandatory. So I am going back here, and basically, again, student is mandatory and must be mandatory because I cannot create an assignment without a student. So it's again, it's a strong relationship. I must have here mandatory, but for the assignment we need to decide if it's strong or less, and I will put you the specifications, the requirements again for you to detect if the assignment is mandatory or optional, and this will be query 5. Okay, so let's see what we have. We have a student must have an advisor assigned when enrolling to the college. So I know that I must assign, as I enroll the student, I must also assign an advisor. And why I do that? Just to be sure that the student will have someone to ask questions to get feedback. So I want to enforce this in my database, so to be sure that always a student has somebody to ask. So that's why I need to keep this one mandatory. And I have this in the specification. Student must have an advisor assigned when enrolling to the college. So now I got a good many-to-many relationship. And you see how I found all the answers in my specification. So this is the lucky case where the specification is giving me answers. Sometimes you may have even more information more information about this relationship. For instance, an advisor has many students assigned, and let's say, but not more than 100. So we don't want to overwhelm the advisor. So if I have such a situation, what will change? What is changing in my diagram, and what is changing philosophically speaking about the relationships? So this will be question 6. Very good. What is changing is another notion related to a relationship, which is a cardinality. All relationship, all entities participating in a relationship have a given cardinality. Some of them are implicit. So let's look on this diagram, and I will discuss the implicit cardinality. For instance, student here in advised by has a cardinality 1-to-1, because I always have at least one student and at most one student. So basically, I must have one student. So if we want to mark these on the diagram, and generally I don't mark the implicit ones, but if you are asked to mark them on your diagram, you will put something like this for this implicit cardinality. So it will be not to 10, 1-to-1. I don't know. Okay. So this will be like an implicit cardinality. And again, I generally don't put them, and you don't need to put them if you, except the case, sometimes in some homeworks, just for you to exercise, you are asked to put explicit cardinalities as well. So now if I want to look at the assignment, again, I don't have any restrictions. So it's basically one-to-many. And generally, that's what we put, one-to-many or one-to-infinity. I will not put infinity here because I don't have easily the symbol, but what you can put always is one-to-many, where many basically means I can have any number of such elements, and the cardinality will be 1-to-infinity. Sure, it's not infinity because you cannot put infinity elements in computers, in databases. That's why many people prefer this one-to-many, where m represent any big numbers that you can have. So now for advisor, again, advisor is required that I need to have at least one, and I cannot have more than one. So it's a 1-to-1 here for advisor. So this will be also an implicit one. So up to now, I put only implicit ones, as you can see. But as you observe, now first time I will have also, and again, don't put cardinality, my recommendation, don't put implicit cardinalities if you are not asked to. If the specification of the problem tells you mark all cardinalities, then you need to put this information on the diagram, even if it's trivial. You can see it based on other symbols, but I am asking you just to exercise the idea. The only one that is really required is this cardinality for assignment. And here we need to think which is the minimum value and the maximum value that I can have. So I take an advisor, which is the minimum number of assignments for this advisor and the maximum number of assignments for this advisor. And that's how I get the cardinality of the relationship, how many entity instances I can have assigned to one entity instance. So that's how I get it. So let's take another color. I'll put here green, for instance, just because I want to mark that this needs to be put on the diagram. Always you need to put this on the diagram. So if you have such a situation, you must to put the information on the diagram. And first of all, I need to look at the minimum value. And generally, this is given by the participation. I already decided that this is optional, so I must have a 0 here. So so it will be the minimum number will be 0, because I can have an advisor may have no students. So the minimum is real 0. Now, the maximum number, I added this in the specification, is but not more than 100. So the maximum number will become now 100. So for a given advisor, I can have the maximum 100 assignments at a given time. So now you can see that I have this new indication on the diagram that always must be there, even if I am not asking you specifically, because it's in the requirement. So this is something that you always put on the diagram. It's a special cardinality, and you must mark. And it's generally written here above. And you may have various notations, can be in between parentheses. Some people may put them in between right parentheses or other type of notation. Doesn't matter. Important is to have these two numbers on the diagram for above that particular right end of of the relationship, because this is the cardinality of assignment in advises relationship. So I need to put it near assignment, the cardinality. Okay, good. Now let's see. So this was the many-to-many relationship. I will not do the next one, but we may do it in a future online session if will still be of interest. But let's imagine our situation when I have a one-to-one relationship, and I will just formulate the situation. Imagine that you have a financial company, and you have very rich persons advised by this financial company, you know, multimillionaires, billionaires, people that have a lot of money. Then basically you'll dedicate more than one advisor, but let's say in this company, the policy is to have a dedicated advisor for this rich person. So an advisor will have a person advised, financially advised, and that person will have assigned one advisor for financial advising. So you will have, in that case, you may imagine that you have a one-to-one relationship. You have a person working for that to advise that particular rich person. So that will be the example of a one-to-one relationship, because you have one advisor for one person and the person has a dedicated advisor. So that's the same kind of advising strategy, but now we have an advising from one-to-one. And by purpose, many of the questions in your test are covering, they are very similar, but the wording is changed. So you may have a one-to-one, a one-to-many, a many-to-one, or many-to-many for the same kind of situation. But changing the wording, it will change the type of the relationship. So be careful, read the problem. Don't try to remember which is the answer, because it will be hard. Try to read the problem and try to answer these two questions and see, determine for the specific case the type of relationship.